Good evening, everybody. We're going to be going over lesson 6-2, drawing inferences from data. This is the homework video that you should be using to make sure your answers are right and to put your answers down on your answer sheet and submit to me. It says here, Alicia and Thea are in charge of determining the number of t-shirts to order to sell in the school store. Each student collected sample data from the population of 300 students. Alicia surveyed 50 students in the cafeteria. And let's see, and Thea surveyed the first 60 students who arrived at school one morning. Let's see, it says here, the results of Alicia's survey. So 30 kids out of, let's see here, 30 kids out of 50 said that they would like shirts. So that tells me, use Alicia's data to estimate the number of t-shirts that to order. That should be 30 out of 50. And then that's going to be equal to, well, the bottom part is going to be 300. Why? Because there are 300 students at the school. This is our sample, and this is what we want to know. How do we solve stuff like this? Well, I'm going to go ahead and use my pin here. And this is really cross multiplying. We learned this in class, right? And we're going to multiply 30 times 300. And that has to be equal to 50 times x. Now this is going to be 9, because 3 times 3 is 9, and then 3 zeros, 1, 2, 3. And now that we have 9,000 equals 50x, I realize I have to divide 50 away from x to get x by itself. Whatever I divide from one side of the equal sign, I'm sure to divide from the other side. And that's going to give me about 180. So let's see if I'm right. Very good. 180. So they should order about 180 t-shirts. Let's go to number 9 now. It says the results of Thea's survey is 50 out of 60. They would like, 51 people would like t-shirts out of the 60. So use Thea's data to determine this. Well, again, this is going to be 51 out of 60. And again, we got 300 students, so that's going to be 300. Once again, we're going to take 51, multiply it to 300, and that has to equal 60x. We're multiplying these together, and they have to equal these together. Well, 51 times 30 is going to be 1,000, let's see, I'm trying to do this in my head as best I can. Yeah, I'm going to go with 15,300, and that has to equal 60x. Once again, I'm going to divide 60 from here. Whatever I divide from one side, I divide from the other side. And that's going to give me about, I think, 255. You can check your calculators if you like. Hope I don't make a mistake and embarrass myself. Let's see what our answer is. Hey, look at that, 255. So that tells me that they should order, according to Thea's survey, they should order 255 shirts. Now it says Alicia and Thea, they're taking their data and they're saying, can Alicia and Thea make a valid inference and explain? Well, no, they can't. There's a big difference in the result of the survey. Remember, Aaliyah had 180 kids out of that group of the 300, and Leah, or Thea, she had 255. That's a huge difference. So the data does not support the same inference. While both sample sizes are large, the data were not corrected randomly, so the samples are not likely representative. They cannot make a valid inference. And why does it say that they weren't collected randomly? Remember, Each student collected sample data from a population of 300 students, but Alicia surveyed 50 from the cafeteria, while Thea surveyed the first 60 kids who arrived in school. If you're one of the first people that gets to school, you might be one of those kids that's a go-getter and really into your school. Maybe you have some clubs or something you belong in, or sports that you're practicing for. They might have a better notion to go ahead and purchase T-shirts for their school than people in the cafeteria who might not normally care about wearing a school T-shirt. Next, it says 3 of the 5 medical doctors surveyed by a biochemist prefer his new approved brand X as compared to the leading medicine. The biochemist used these results to write the TV advertisement shown. Is the inference valid? Explain your answer. Well, when they ask me if the inference is valid, I have to remember what is an inference. It's information that I can take about what was said and make a valid conclusion from it. Now, this advertisement states that 3 out of 5 doctors prefer brand X medicine. But in this example, it says 3 of 5 medical doctors surveyed by a biochemist prefer this. He only asked 5 people. I mean, really, that's not a big enough sample. So I'm going to say no, that it's not valid. A sample of 5 is not large enough to represent the entire population of doctors. There's not enough data to support the biochemist's inferences. Aaron conducted a survey of the type of shoes worn by a random sample of students in the school. The results of the survey are shown over here. 12 of the kids wore sandals, 19 of them wore gym shoes, and 6 wore boots. Make a valid inference that compares the number of students who are likely to wear gym shoes and those likely to wear boots. When I compare gym shoes to boots, I can see that, well, there's almost 3 times as many gym shoes. In fact, there's more than 3 times as many people that wear gym shoes as boots. That's an inference I can make based on the information. About 3 times as many students are likely to wear gym shoes as boots. Part B says make a valid inference that compares the number of students who are likely to wear boots and those likely to wear sandals. Well, since boots, there's 6 kids that wore boots and 12 that wore sandals, that means half as many kids are wearing boots as sandals. About half as many students are likely to be wearing boots as sandals. Number 13 says Chantel and Cyrus are searching the types of novels that people read. Chantel asked every 9th person at the entrance of a mall. She infers that about 26% of the population prefers fantasy novels. Cyrus asked every person in only one store. He infers that about 47% of the population prefers fantasy novels. Whose inferences is more likely to be valid? This one's pretty easy. Chantel. Chantel used a sampling method that is more likely to result in a representative sample of the entire population. Remember, she asked people that were entering the mall. Some of those people don't even read novels at all. So this was a very impartial random survey based on the entire population, not just the population of people in a store, okay? Every person in one store, 40%, is only going to go ahead and give me the information from the people in that store. And what if that store, let's see, they're talking about fantasy novels, what if that store was a game store? And those particular people really like gaming. They're going to get into fantasy type of things. Let's go to letter B. What mistake might Cyrus have made? Well, about half as many students are likely to be wearing boots as sandals. Okay, I had to make a little correction there. As you might be able to tell, Mr. Morgan made this slideshow and he put the wrong answer there. So I went back and made corrections and then started the tape again. What mistake might Cyrus have made? Like I said earlier, Cyrus might have chose a store in which the majority of customers enjoy reading fantasy novels. All right, let's go to the next one. High order thinking. The national TV news shows conducted an online poll to find the nation's favorite comedian. The website showed the picture of 5 comedians and asked visitors of the site to vote. The news show inferred that the comedian with the most votes was the funniest comedian in the nation. So it looks like they picked comedian 3 here. What is the inference valid? Well, the inference is not valid because not everyone has access to the internet, and there were only 5 comedians to choose from. I mean, let's face it, there's tons of comedians out there, and if you're going to go ahead and have a survey for who's the funniest comedian, you really need to have a platform with more than just 5 to choose from. Not to mention the fact that a lot of people watch comedians live. They don't have internet, and even if they do, they don't watch them there. So by going ahead and stating that this inference could be valid, you would be incorrect. How could you improve the poll? Well, expand the poll to other locations. You might put it to tallies that you have coming in and out of a store. Remember, they said here, they conducted an online poll. You could have people standing outside of a mall asking random people to come in. You could even go ahead and put a letter in the mail asking different addresses at random and seeing which people write back to you. In 15 and 16, it says to use the table of survey results from the random sample of people about the way they prefer to view movies. Lindsay infers that about 400 people, 300 out of 400 people, 300 would prefer to watch movies in a theater. Is her inference valid? Well, they said here that 30 would like to watch it in theaters. Streaming it, that 62 would, and with a DVD, 8 people would like to. So when she infers that out of 400 people, 300 would infer watching movies and trailers, we have to set up that little percentage again. And if I was going to do it, I would have to add all these up. Well, 62 and 8 make 70, and 70 plus 30 is 100. So that means when she says movies in theaters, that would be 30 out of 100. And since she's talking about 400 people, we have to cross multiply again. Well, 3 times 4 is 12. And then we got 3 zeros there. And that has to equal 100 times x. Well, this is pretty easy because we'll divide 100 away from x. Whatever I divide from one side, I divide from the other. And I know I can just start crossing out my zeros here, and that's going to give me 120. So she infers that 400 people would prefer to watch movies in theater. Is her inference correct? And I'm starting to really have some issues with this here. Sorry. No. The sample answer, in the sample answer, 30 out of 100 prefer to watch TV in theater. So that's about 120, which is what we came up with, out of 400 would expect to prefer to watch movies in a theater. Does everyone see how I got that answer? Which inferences are valid? Select all that apply. Going to a theater is the most popular way to watch a movie. Not sure about that. About twice as many people would prefer to stream instead of watching in a theater. Well, that's true. 62 is about twice as many as 30. About 3 times as many people would prefer to watch a movie on DVD instead of watching it in a theater. No, actually, that's about the opposite. 1/3 of the people would like that. About 3 times as many people would prefer to watch a movie on a DVD instead of streaming. 8 times as many. Oh, well, yeah, I'm thinking that's close to that because 8 times 8 is 64. Let's see. I said 8 times as many people would prefer to watch a movie on DVD. Oh, instead of streaming. I'm going to say that should be the opposite. Most people would prefer streaming over any other method. Yes, I could definitely say that. So I'm probably going to go with the second and the last one being the right answers. Next it says, Monique collects data from a random sample of 7th graders in her school and finds out that 10 out of 27 7th graders participate in after-school activities. Write and solve a proportion to estimate the number of 7th graders who participate in after-school activities if 197 graders attend the school. Right here we can see that 10 out of 25 has to equal some number out of 190. We'll multiply 190 times 10, which will give us 1,900, divided by 25, and that will give us 76. Number 18, each of the 65 participants in the baseball camp attempt 20 free throws. Let's see, Mitchell collected data for the first 10 participants, which of whom were first-time campers. Lydia collected data for the next 10 participants, most of whom had attended the camp for at least 1 year. Using only his own data, what inferences might Mitchell make about the median number of free throws made by the 65 participants? Remember, we're only using Mitchell's data, and we're talking about the median number. Well, the median number is the one in the middle, and that's going to be about 9. So I would say, based on Mitchell's data, the median number of free throws is 9. Next, it says, using only her data, what inference might Lydia make about the median number of free throws made by the 65 participants? Once again, her median's in the center, and that's going to be about 12. So that means, based on Lydia's data, the median number of free throws will be 12. Who made a valid inference? Well, this is greatly going to depend on what? Well, let's look really closely. He collected data for the first 10 participants, most of whom were first-time campers. He totally ignored the people that had been at the camp before. Lydia did just the opposite. She asked the people that had been to the camp at least 1 week. She didn't ask the people that were first-time campers. So Mitchell's sample included mostly new participants who had been less than skilled, while Lydia's sample included participants who had been at the camp longer and may have been more skilled at shooting free throws. That's it for tonight. Glad you were able to watch, and I'm looking forward to seeing your papers turn in.